Okay, let's get into this. So we're going to talk about writing to standard output into files first. The reason being is that these are going to be very similar processes. So writing to standard out. To do it, we're going to include include IO stream. When writing to standard out, you're simply going to insert the objects or literals into the stream in the desired format. For instance, if I'd like to output name followed by the contents of the variable name, followed by number in the contents of the variable number, in this case 11. To write that out to the terminal, I would simply insert the string literal name first, and notice the direction of the insertion operator. It's saying the information is traveling or pointing into the stream. So name will go in first. After that, the content stored in the variable name will go in. After that, another string literal. Once that's processed into the input stream, next up is going to be number followed by a line feed. And at that point, this would have appeared within the terminal window to the user. Now let's say we want to write out the contents of a user-defined type. Maybe this is to check their values or to actually present this information to the users. So we have contact. We built this up when we were talking about structs. And let's go ahead and assume that this is we initialize a person somewhere. We'd like to go ahead and output the contents. We can't simply write person, assuming that person is a contact, because that operation is going to be undefined for this user-defined type. Just like if we had, say, a vector of ints, we would not be able to simply insert this vector directly into the stream as such, because that operation is undefined as well. For the vector, we'd have to iterate through each of its elements and go ahead and output the results. If each of its elements were a contact, we'd have to essentially visit each field and explicitly print it out as we're showing here. The good news is that once we get into classes in the near future, we'll talk about how we can overload the insertion operator for both vectors or for any of our user-defined types to allow us to use notation such as this or that and inserting objects of those types directly into a stream. But right now we don't have that capability, so we're going to have to use the method presented or described. Now, writing to files is going to be no different than writing to the standard output. The only difference is that we're going to have to bind a stream to the particular file that we would like to write to. In order to interact with file streams, we're going to have to include fstream into our application. When writing to a file, we're simply going to insert the objects or literals into the stream in the desired format, exactly as we did when writing to standard output. So here's the first, new line here. We're creating an output file stream. That's the OF portion of the stream, output file. We're going to name the output file stream OFS. So that is the name of the file stream. And then I'm going to provide the name of the file that I would like that stream to be bound to within this curly brace notation here. At the end of this statement, OFS is going to be bound to the file name.extension. The next thing we're always going to do is check to see whether or not that output files, whether we were able to open that file. So we'll write something like, if the file is not open, we'll do something. We haven't talked about error checking at this point, but if this is in a function, we'd be talking about perhaps throwing an exception. If this was just a main, it might be printing an error message to the user and returning one to signify that, hey, this application did not terminate successfully. And really, any non-zero integer value returned from main communicates that. 0, on the other hand, would have communicated success. So let's say I have two variables, a string name and an integer number. Notice that the only thing I've changed here in outputting this is the stream that these objects would be inserted into. You could see this if OFS was replaced by cout, you would know exactly what was happening because it would mirror that of the previous slide. Here, the same underlying process is occurring. It's just that this output is being directed into the file name.ext. And after executing this statement on this line, the contents of my file, contents, not the name, the contents are going to look exactly as so, because that is the format that we wrote the information to the file in. I could have put a line feed in there. I could have put tabs. I could have formatted the contents of the file in any manner that I would have liked. And for some extensions, there's a prescribed format that you'd follow to adhere to the expectations of that format. So, writing to files. Be careful. Binding a new file stream to an existing file will overwrite its contents. So let's say file name.extension has something really important in it, some data you've been collecting for a while. Then you go ahead and bind a stream to it and then compile your program and run it. Right when the thread of execution goes over this statement, the contents of your file have been overwritten. So if you would like to instead append, that is add to the end of the file, opposed to overwriting its existing contents, you must specify this intention when you're binding the file to the output file stream. To do this, it's simply, the curly braces kind of become we'll call it a parameter list. And the first argument here is going to be file name.extension. The second one, in the case of appending, is going to be this right here. And you can think about this as essentially communicating to the output file stream object that's being constructed that, hey, you're actually going to be adding to the end of an existing file. And it will ensure that this happens in this manner.